Hello, everyone. It's time again for the SMC Journal podcast, the show that's all about software engineering and modern IT. It includes testing, tuning, observability, security, AI, and much, much more. I'm Scott Moore, your host. Thank you for joining me today. This show is a two-part podcast that's going to begin today, and it's part of a presentation that I did earlier this year in 2023 about questions that come up all the time for me as a person who's known for the performance testing world, load testing. I've done it for decades now. It always arises, Scott, if you had to show us the basics, just if you can put everything in the smallest capsule possible and show us in a few minutes, what do we need to know if we're going to start doing load testing? How do we do it right? What's the proper process? And it doesn't matter if you're doing waterfall, agile, DevOps, whatever, and whatever your culture is. Can you give us something that is repeatable that we can at least start with and maybe even improve upon that? But give us something to go on. Yeah, I get that all the time. And so I wanted to do a presentation about that. And I also wanted to tweak it a little bit and make it a little fun. So this is a presentation I have called Load Testing Like a Rockstar. So there's a lot of references to rock and roll and heavy metal in the thing. And it's basically about what are those basics that make up the process of load testing an application, and then what goes into the types of tests that you run, and what type of output should you expect. And can you share with us some real examples, Scott, of how this has been successful for you? And yes, I can. So I wanted to take this opportunity to share that with you over, because it's too long to do a single podcast over, so I broke it up into two parts. So that's where we're going to go today. But before we do, let's talk about the sponsors that make this show possible for you to watch. This episode is sponsored by OpenText, the information company. We power and protect information. Our purpose is to elevate every person and every organization to gain the information advantage. OpenText works to power the ubiquitous information around us to elevate everyone. We strive to help customers simplify their systems with frictionless automation and equip them to thrive and grow in a digital world. The LoadRunner family is one of many solutions where OpenText can help. Did you know that LoadRunner has the largest community of load testing professionals in the world? Check out the QR code or go to their website at opentext.com to find out more about the LoadRunner family. Do you need unbreakable network connectivity? West Networks can help. They're a leading provider of PEP-Link-based SD-WAN solutions, and they can help you achieve unbreakable connectivity by utilizing PEP-Link's SpeedFusion bandwidth bonding technology. Since 2012, West Networks has been assisting those in the mobile health services space by providing communities with access to life-saving technology. They also work with mobile command field units like first responders and news agencies, delivering faster and reliable access to mission-critical information all the time. Whether you're an IT professional who needs to work from anywhere or a full-time vacationing traveler in the RV community, West Networks can help you stay connected all the time from anywhere. Large enterprises can save up to 83% off cost while expanding communications and reliability beyond a single carrier with West Networks PEP-Link-based SD-WAN solutions. They can help you replace expensive MPLS connections with SpeedFusion's site-to-site unbreakable VPN technology. So no matter what your needs are, West Networks can help you achieve unbreakable connectivity. Contact them today to learn more. Thank you so much, sponsors, for showing leadership in the area of supporting the community around software engineering. We really appreciate it. And with that, let's go to our presentation about load testing like a rock star. I'm a performance engineer and have been doing so for over 25 years. I'm going to share what I think is a pretty foolproof method for doing load testing, whether you're doing that around web-based applications, something else, you're doing it in an agile way, a DevOps way, a waterfall way, doesn't matter. And obviously, I can't teach you everything I've learned in 25 years, but I think this is distilled down to the biggest highlights that I've learned that will help you no matter what project you're doing. And in fact, I'm so confident in sharing this with you because I've never had any application that I've tested through this process actually fail in production once it rolled out. So with that, let's get started with the presentation. And those of you who are familiar with rock and heavy metal, you'll get the references in here. If not, just hang in there with us, okay? So let's talk about the agenda. I'm going to talk to you about what a load test really is, and what I consider it to be is a symphony of destruction. It is an organized, orchestrated mess of chaos that's done in a controlled way so that you can find out if your application is too risky to roll to production, that is it going to go down under a certain amount of load. Maybe it works great for one user or a few, but can it work well for the population that you're planning on servicing with that application? We'll also talk about what I call a solid performance testing process that you can utilize for every project from this going forward, and I think that it will help you. I'll also share a couple of what we call war stories or road stories along the way. So with that, let's get started. I want to show you this picture here because this process, this circular process, is an agile way of giving you the entire load test process as I do it. Now, if you just kind of stretch this out with no, repeatability, there's a waterfall way to do it. But it boils down to 4 different areas: planning, building something, executing something, and confirming that what you've done either meets the requirements or it's met the objective that you're attempting to reach or attempting to prove out in a test. I would say if you focus on nothing else as a new load testing professional, planning. I was always guilty of ignoring the planning phase when I went to classes to learn how to use a load testing product. I thought I had it all together, and then when it actually came time to do the load testing, I found out I knew how to use the tool, but I couldn't put it into context to that particular application because I didn't listen, and I didn't create a repeatable way of planning out a test. What are the questions that you ask? What kind of information do I need at my fingertips to put together this perfect storm that a load test is supposed to be? It's just non-technical questions like, who are the users? What are they doing? How often are they doing these things? And then those technical questions. Okay, well, as they're doing these things, what's the technical stack that they're using? Which one of these business processes, how does it affect the back end? How does it impact the database, for example? All of these types of questions come into play. You really want to have a list of standard questions that you use to build out a planning, it doesn't have to be a formal document, but a way to organize all these thoughts and the answers to these questions so that you know how to build good load test scenarios. So it's analyzing the user behavior, the application itself, and the objective that you're trying to reach, which, by the way, should be probably less than 2 objectives for a test. You'll probably find out a lot more information that cover other objectives, but try to limit it to 1 objective if you possibly can. What is the objective of the test? Is it to see if the infrastructure can hold under the pressure of all this load? Is it the application? Is it end user experience? I mean, it's probably going to be a lot of everything, but find the most important thing and focus on that and build your test around that. Second phase is building something. This is where you actually go in and automate business processes where you're trying to create that perfect storm in terms of what people are doing. Here, I use the 80-20 rule. 80% of the load on an application is usually done by about 20% of the users and the personas. And it's the common traffic, and it's those things that we look for that exercise the back end, we call it. So things that would cause the database to work very hard on would be an example of that. If you're doing a shopping cart, the actual purchase of something that creates dynamic data. Every time you make an order, something new is created, and there's a big process that happens on the back end. So those type of being able to design automation that does exactly what end users do and takes into account all of those dynamic things. Like when you're creating an automated script and you have to fill out a form, not everything in that form would be the same information. You want to submit different information to cause the back end to work harder. The same respect, when that form is submitted and that information is processed, dynamic information is created and sent back to you, and your automation needs to be able to handle that without any problem. Execution is taking all of those automated business processes and putting them together in such a way that you are mimicking what real life in production would look like, or as close as possible. Sometimes it's not possible to get every single thing, but you're trying to shoot for as close as possible in a pre-production environment. At the same time that you're creating this test, many load test professionals, when they first get started, they'll pull down an open source load test solution and they'll iterate, they'll create some automation, and they'll start generating load. And the value that comes from that, there's some value to it, but not as much as if you combine the timings that you get from a load testing tool with the infrastructure monitoring, application monitoring, database monitoring, monitoring specific things under those conditions, so that when you get timings and transaction times that are higher than you expect, you can dive down into the additional data points that you have to find out, where is that problem? So I always talk about it being having a problem like a needle in a haystack, and you've got a lot of haystacks, and every single tier of your application is a potential haystack with a problem, a needle in it. So how do we find that needle in a haystack? By gathering the transaction times. Let's say that a search was supposed to come back, we are expecting it in 3 seconds, and that's what we've set as an objective, that everything has to be 3 seconds or less from a timing perspective, and a search is taking 30 seconds. Well, why? That's the next question that's going to be asked by everybody. Generic load testing tools without monitoring won't be able to tell you that. You'll need additional people, additional information to get that. That's why I prefer to have a combination of a tool that gives you the transaction timings and also allows me to set up monitors that happen real time under that load that will tell me, well, this search is taking a long time. What else can I look at that would possibly lead me to a root cause of this problem? And so I might start looking at the database, and the database might be under more load than we expected, and we can kind of dig into there. Now we've identified the haystack, and then we might actually need help from another professional, a database administrator, to dig even deeper into some of those metrics to find out why. Well, it's because we missed an index on this database table that you're searching for. Let's correct that, rerun the test, and all of a sudden now we're at 3 seconds again. But without that 360-degree view of monitoring plus transaction timings, you may not be able to find that as easily. It may take you a lot longer to come to the same conclusion. Once you have finished executing these tests, and we're going to dig into the types of tests, the type of test scenarios that we want to run, because that's a whole nother conversation, the confirmation of the test results. So you will hear me, if you ever hear me talk, I will say this many times. The value of any load testing tool or exercise is all around the analysis, the results that come out of that test. They're only good for a limited amount of time. You ran this test, you got the information. If the information you get out of that load test is not actionable, meaning you can't do anything with it, then why did you do it? Why did you gather this information? So that's another reason why planning what you want to get out of this is so important. So confirmation really helps you in reviewing the test results, finding out if there's meaningful information there, finding out what needs to be changed and tuned in the system, and then validate, does this test result indicate to me that I've met the performance requirements, the operational requirements, and the objective of why we did this test? If it does, great. You're able to go back to the stakeholders and say, we have lowered the risk of rolling out this application because all indications are this is going to be fine under these levels of load. And also to document any changes, because the first few tests you run, you might have actually run into issues where it didn't meet the requirements. So things had to be changed. You'll want to keep records of that and make sure you know what you did, so that the next time you have to test something like this, you won't run into the same problems. And I'm not saying you have to be, super over documenting of everything, but pertinent documentation is the key. The type of results that you give back to your stakeholders doesn't have to be a 50-page report. Sometimes it does need to be a 50-page report when warranted, but sometimes it's as simple as a one or two graphics, one or two graphs that you're able to put together, especially for the team, and show here's what the results show. Here's the final test, and it shows that we are able to meet the specs by this information. So it really depends on the organization and the level of testing that you're doing. But if you put these four things into practice: planning, build out a planning and strategy, some kind of a document, some way to coordinate the information, a standardized way of creating the automation with the tool of your choice, executing in a systematic way, which we're going to talk about next, and then having really good test results and analysis that tell the story, that you're not making up the story, you're actually taking the information from the test results and letting the truth rise to the top. That sometimes is an art in and of itself. And for those of you beginning, just realize that's the start of your journey. Sometimes we refer to being able to report good analysis as sort of a dark art on its own, because it takes you down many rabbit holes. And sometimes you have to spend a lot of time to bring out what this application is trying to tell you. It may not be the first set of results you get from a test, and you may have to dig into a lot of raw data to really find out what's happening. Let's talk more about this Symphony of Destruction that we mentioned earlier. Now, this is all encompassing around that execution part of the process that I mentioned. So we're going to talk about the types of tests. There's 6 of them here that I'm going to talk about, and I guarantee you, if you do your testing this way, you will find problems early, and you may not even have to run all these tests. And if you do find them, you can stop wherever you're at, address the issue, and tune that application as you go. So I'm going to use some terminology here that may be different from some people, but this is the way I define it. Use your own words in substitution to it. But when we talk about baselines, what I mean by that is running a load test where it's one business process, one single user, gathering the timings over a period of time. So let's say that I'm using a load testing tool. I've already got all of my recordings, my business processes automated. I bring up the first one, I load it up as a single virtual user, and I might run that for a whole hour, and I'll pace it out like a real user, like with pause time, think time, and everything. Just run that along, gather timings, and for all of these tests, I'm going to be monitoring all those things. So I'm going to have found out how do I best monitor this infrastructure, the application, the database, all those things without over monitoring. I only want to put maybe 3%, 5% overhead max on a system just by monitoring it. But I do want to gather enough information to be able to find that needle in a haystack, as we referred to it earlier. But gathering this timing per script, per automated business process is very important, because as we said earlier, if something's taking a long time, like if I do a search and searches are coming back in 30 seconds and they were supposed to be 3 seconds, and it's happening under a single user, well, why would we need to run 1,000 user test for that? We should stop, find out why it's 30 seconds, and eliminate that. Hopefully, as a good performance engineer, before you ever ran a load test, you went into the browser yourself, or you went into the application with your own little watch, your stopwatch, whatever you have, manually go through it. Look, if it's a browser, open up the developer tools option and look at everything that's coming down and how long it's taking per page. But time it. If you do a search and search takes 30 seconds, it's pretty easy to notice that that's a bad timing, and that's what end users would experience. So you might want to start tuning before you ever even run a load test. And all a load test is going to do is validate that, yep, you've got a problem with search. So start with the baseline and feed that information to the people who need it. Most of the time, that's going to be the technical people. Why is this so long for this time? What's different about that? From there, if you find out everything's cool, then it's time to actually look for top time transactions. Now, what I mean by top time transactions is you don't want to just go out there if your objective was, we need to run 1,000 concurrent users running these automated business processes for 1 hour. You don't just throw 1,000 users out there. Obviously, you ramp up to those, but Sometimes those objectives are way more destructive than we think they are. Like, the system is expected to handle 1,000 concurrent users, but the environment as configured could probably only handle 100. But as we start ramping up, we're only 10% done with our test and everything's already crumbling. So what we don't want is a lot of surprises. So what I'll typically do is whatever objective has been chosen by the business, 1,000 users, we'll say, 1,000 concurrent users doing these things, I would ramp up to only about 20% of that number. So I'd set it to say 200 concurrent users, and I would still ramp up over a slow period of time. My ramp ups are usually 20 to 30 minutes in time, and my test after ramp up is usually a whole hour. I'll tell you about why that is in just a moment. But 20% of that number would be 200 concurrent users. I would ramp up slowly to 200 concurrent users, hold it there. And if the environment is as great as we think it is, it should be able to handle 20% of the load with no problem. However, you will begin to see a theme. You'll begin to see trends happen and patterns, anti-patterns, I would call them. You will start seeing negative transaction timings occurring at certain places. And just like with your baseline, you'll be able to determine, well, it was fine with single virtual users now, and maybe we threw a handful of users at it and it was fine. But now at this level, I'm starting to see that the search has creeped up a lot more than the others. And that's what we call a top time transaction. We look at the timings. It's 1 second, 3 seconds, 2 seconds, 30 seconds, 2 seconds. Okay, we found a top time transaction. Let's isolate that and find out why that is. What's different about it? When we go through the happy path and we look through the whole architecture, what makes that take longer? Is it going through more services? Is it going somewhere different? Is it going to a different server? Is there additional calls? Is it waiting on something? Those are the kind of questions that will be asked when you isolate those top time transactions. But let's say that we don't have any and that everything's still fine at the 20% level. This is where I talk about the 100% test, or what I would refer to as a benchmark test. So the baseline would be single virtual users, but a benchmark is, can we reach the objective we thought we wanted to reach? So 1,000 concurrent users. I would ramp up slowly, again, 30 minutes, let's say, to reach 1,000 virtual users, hold it there for an hour and see what happens. Now, let's talk about why that's an hour. Because if I make it to the full objective, what I want to do is hold that test at that peak load of the objective for a unit that we can easily define. And so the way I'd say it is, if we can hold this load for a single hour and there's no problem, we can probably handle the other 23 hours in the day, because if this is the peak load, there isn't anything heavier than that, so everything else is going to be easier, right? But this ramping up, if we do make it, we want to chop off that ramp up time, because all the way up to 1,000 current users, we probably had really good times. They looked great until we start getting to this level here. You're probably going to see increased time values as resources begin to be depleted. So as we hold that at 60 minutes and we chop off that ramp up time, we're going to see the worst possible numbers, worst possible transaction timings. And we want that because we want to be more conservative in what we report as our 90th percentile, 95th percentile number when we say it's taking this long for a user to do this thing. All right. Now, let's say that we don't make it. We tried to make it to 1,000 users, but we didn't make it. Well, we're probably just going to isolate the ramp up time at that point and say, at this number of users, this transaction fails the requirement, or from the monitoring, this monitor indicates that this resource has gotten depleted. So at 127 users, the database is overloaded with the CPU. There's too much queuing. This is just an example, but you will isolate those things. And again, you haven't reached your benchmark. So you would tune that application until you got to that point. And the benchmarking then is, can we reach that objective, that 1,000 user objective? So do you feel like a rock and roller yet? Can you think you could jam with the band? I'm inviting you to be part of that. I'd like to know your feedback about this content. We'll finish it next week on the next podcast, and you'll get to hear a lot of how we finish out the types of tests, and also real stories, some real graphs, and some real reports that you can look at to show how I can prove that this stuff actually works. But I'd like to get your feedback if you like this content on this program. If you do, I'd like to hear from you. You can reach me on most social networks. If you scan that QR code, it'll take you to my bio page where you can reach out to me several different ways online, not the least of which is to send me an email to heyscott@smcjournal.com. Would love to hear from you. If you do like this kind of content, it would be great if you liked and subscribed to the channel. Like that video, ring the bell, do all the things that lets me know that I'm doing the right thing regarding the content here on this program. So until next time, this is Scott Moore saying thanks again for watching, and we'll see you on the next SMC Journal podcast. Bye-bye.